Okay? All right, everyone, let's get started. We're going to start with something that might be a review about resistors in series, but we will use that to build up into some concepts very relevant for biomedical instrumentation. But actually putting resistors in series is something so basic. It's almost like the most basic thing you can do in circuits, right? And the basic idea is that if you have two resistors, and in series means that they're sort of tail to head, right, one to the other. And you have one, let's call this R1, and then you have R2. You can represent this by another resistor. I'm going to call this R equivalent, right? And R equivalent is R sub 1 plus R sub 2. So for example, if R sub 1 was 1 ohm and R sub 2 was 3 ohms, then the associated R equivalent would be 4 ohms. And this is something that, in fact, you know, I'm sure is very, very familiar to you, right? This was sort of where you started circuits. Now, and so they'll say, right, this resistance is equivalent to that. But my question is this: what do we mean by equivalent? What do we mean by equivalent? I mean, if you have two resistors, right, it's not that by some magic you make it into one resistor, right? You still have two resistors. So when we say R equivalent, what do we mean by R equivalent? What we mean is it's R equivalent from the perspective of, in this case, Ohm's law. So here we go, back to Ohm's law, right? So Ohm's law tells us, right, we'll put it right here as a reminder, right, that if you have a resistor R, let's not label it, with a current across it called I, voltage equals current times resistance. And this is the component, right, that we're interested in. Okay. And so what it's saying is that if we look at the voltage from here to here, right, let me just call this, let's say this is the voltage positive terminal, and this is the voltage negative terminal. And here we have the voltage positive terminal and the voltage negative terminal. It's saying from the perspective of Ohm's law, this acts the same as that. That's what we mean by equivalent. So that the current here, let's call that I, well, just one I, is going to be, let's call it delta V, right? This voltage here over R equivalent is equal to I. And similarly, I'll just put an equal here. This voltage, we're going to say what's the same voltage is applied over R1 plus R2. So that's what we mean by equivalent. It's equivalent from the perspective of Ohm's law, right? That's all we mean. All right. So that's a review of that. Okay. Now, previously, we talked about the voltage divider. And as I hope is now familiar, we'll put up again, we have E, we'll call this RB, we'll call this RA, and we're measuring the voltage A across from here to here, right? And I said you can derive what voltage A out is, right, using Ohm's law, right? And I think the way I did it last time, it was a little bit clunky. I was like applying Ohm's law here, I was kind of applying Ohm's law here, right, in a different way. Let's just go through it in 30 seconds again, just using this idea. So we have a current, and it's a single current running through the entire system, right? So I have a voltage, and I have a current flowing through two resistors. But let me consider these as one R equivalent, right? There's a resistance here and the resistance here, but I can combine the two of them to create a single resistance. Now again, do I still have a voltage divider with two resistances? I do. It's just that we can apply Ohm's law now over this entire system. And so now we can say I is equal to, it's going to be the voltage, which is E, over the combined resistance, which is R B plus R sub A, right? That is the current, right? And now, let's apply Ohm's law here, right? And I know you're saying, man, this professor really likes Ohm's law, but here we're taking this fancy instrumentation course. Surely we're going to need something else for this entire course. Well, let's see. Okay. So now I'm going to write Ohm's law here. So that's VA is going to equal R lowercase a times I. And so we have V sub A is equal to E times R sub A over, I'll just swap the order here, R sub A plus R sub B, voltage divider equation. Okay, simpler, and we use the equivalent. But now you know what equivalence means, okay?